Hello there. Our next topic is curing. What is curing actually? It is earlier said that it is just the art of preservation using the salt, but nowadays we will use the nitrite, sugar, phosphates, and many such compounds for preservation. Now, the discovery of the nitrate as a preservation agent or the color fixation agent was just accidental. It came along as a impurity of the rock salt. The nitrate used to convert into nitrite by the bacterial reduction, and the nitrite which will eventually give rise to the nitric oxide, which will help in the fixation of the color in the meat. The subtopic under the curing we will be studying is meat pigment and the stabilization of the meat color. In the meat we will be having abundant amount of the myoglobin, we will be having residual hemoglobin, cytochrome, flavin containing enzymes, and the catalase enzyme. In the uncured meat, what happens is, if the it is not subjected to preservation, then the iron that is present in the meat or the myoglobin, it will be reacting with the oxygen, giving the meat a bright red color. Because it is reacting with oxygen, it will be oxidized. Ferrous will be oxidized to ferric, that will become the metamyoglobin. Metamyoglobin will be brownish in color and it will further degrade, and the degradation of the meat will occur. But when you look the same condition in the case of the cured meat, you will get to know the role of the nitrate here. Firstly, there will be nitrite from which the nitric oxide will be derived. Nitric oxide will be combining with that of the ferrous that is present in the myoglobin, which will be blocking the oxygenation process of the metamyoglobin. Okay, then this nitric oxide myoglobin will be imparting a permanent pink color because the compound that is formed is nitrosohemochrome, the color of the cured meat during the heat treatment, that is permanent pink. The ascorbic acid can be used along with it because it will be helping in maintaining that reducing atmosphere and not enabling that myoglobin to oxygenate, and it will be also not converting the nitric oxide metamyoglobin to nitric oxide myoglobin. Then the preservative function of components, other than the nitrate, we can also use the NaCl. NaCl will be used as an inhibitor because it will impart the inhibitory effect on the bacterial growth. Then nitrite, it will retard the growth of the bacteria, especially the Clostridium botulinum. Then phenolic compound will be acting as bactericidal, and the phosphate will be improving the organoleptic quality and provide the texture, and it will also improve the water holding capacity of the muscle protein. Then salt can be added for taste. Then the toxic factors that can result because of the curing, because of the nitrite, phosphate, whatever you are adding for curing. For example, nitrite, instead of getting converted into nitric oxide and combining with the myoglobulin, it can instead combine with the secondary amine, causing the nitrosamine, which will be carcinogenic to the animal. Then the other toxic factors are benzopyrene and the condensed aromatic hydrocarbon. These are also the well-known carcinogens. If you are not having the nitrite, what all are the substitutes that you can use? Those are sorbic acid, sodium hydrophosphate, phosphide, then fumarate ester, irradiation, acidulation by lactic acid producing bacteria. Apart from the nitrite, other impart the cured flavor to that meat. What are those things? This is ketone, aldehyde, bases, and the sulfur. Then, except addition of the salt, nitrite, phenolic compound, phosphate, and nitrates, we can also go for the smoke method. What is smoke? Smoke will be generally produced by the wood. It will be having 40 to 60% of the cellulose. Hemicellulose will be 20 to 30%. Lignin will be 20 to 30%. And the meat will be subjected to the heat at 200 to 400 degrees Celsius. A typical color and the flavor will be observed in the meat. The phenol and the formalin can be used in the smoke. The phenol will be acting as bactericidal and the formalin will be acting as bacteriostatic. Now we will look on to the types of the curing. There are basically four types of the curing, that is drying, pickle curing, injection brine curing and the pickle injection and the dry cover curing. In the case of the drying, you will be just putting the salt over the surface of the meat and you will be keeping it into the chill room at the 2.2 to 4 degrees Celsius for 7 to 10 days. In the pickle curing, what you will do is pickle solution in which the meat will be immersed. You will be imagining what is this pickle solution now. It is nothing but a salt mixture will be dissolved in the water in which the meat will be immersed at 60 to 65 degrees Celsius selenometer and it will be stored in the cold room store at 2 to 4 degrees Celsius for 5 to 7 days. Then injection brine is the third method of the curing in which the pickle solution in which as in the pickle curing we were immersing the meat into the pickle solution, but in the injection brine we will be injecting this pickle solution into the meat and keeping it into the cold room store, that is 2 to 4 degrees Celsius for 5 to 7 days. Then pickle injection and dry cover in which the meat injected with the pickle solution and it will be followed by the application of the dry salt mix on the surface of the meat and it will be again kept in the cold room temperature, that is 0 to 4 degrees Celsius for 5 to 7 days. I guess the curing topic has been clear. Curing is nothing but a quick summary of it. Curing is nothing but the art of the preservation of the meat by using salt, nitrite, phosphate or the phenolic compound, etc. Then we studied about what will happen in the uncured meat and what will happen in the cured meat when it is cured with the nitric oxide or nitrite, and the other such compounds that are used as a preservative will be NaCl, phenolic compound, phosphate. Then we also saw what will be the toxic factors that will be present during or that will occur during the curing steps, and we also saw if there is not nitrite present, what will be the substitutes that can be used. Then what is smoke and how can it be used in the curing step, and the types of the curing.